characteristics of air conditioning and refrigeration system. 1. Vapor compression system. The vapor compression refrigeration cycle is almost 200 years old, but it doesn't seem able to leave the scene anytime soon. While some people have viewed this method as environmentally harmful and inefficient, but still this cycle remains applicable within the industrial sphere, gas plants, petroleum refineries, petrochemical plants and most of the food and beverage processes. Definition. It is defined as a technique in which an engine works in reverse, technically mentioned as reverse Carnot engine. In other words, it is the transfer of warmth from a chilly reservoir to a hot one. Clausius' statement of the second law of thermodynamics states, "It is impossible to construct a tool that operates during a cycle and produces no effect aside from the transfer of warmth from a lower temperature body to a higher temperature body." Since the vapor compression cycle is against the second law of thermodynamics, some work is important for the transfer to require place. Components of vapor compressor cycle. The vapor compression refrigeration cycle involves 4 components: compressor, condenser, expansion valve or throttle valve, and evaporator. It is a compression process, whose aim is to boost the refrigerant pressure because it flows from an evaporator. The high-pressure refrigerant flows through a condenser or heat exchanger before attaining the initial low pressure and goes back to the evaporator. Let's discuss these processes in more detail. Step 1. Compression. The refrigerant, for example R717, enters the compressor at low temperature and low pressure in a gaseous state. Here, compression takes place to boost the temperature and refrigerant pressure. The refrigerant leaves the compressor and enters the condenser. Since this process requires work, an electric motor could also be used. Compressors themselves are often screw, centrifugal or reciprocating types. Step 2. Condensation. The condenser is actually a device. Heat is transferred from the refrigerant to a flow of water. This water goes to a cooling system for cooling within the case of water-cooled condensation. Note that seawater and air cooling methods can also play this role because the refrigerant flows through the condenser during a constant pressure. One cannot afford to ignore condenser safety and performance. Specifically, pressure control is paramount for safety and efficiency reasons. There are pressure controlling devices to require care of this requirement. Step 3. Throttling and expansion. When the refrigerant enters the throttling valve, it expands and releases pressure. Consequently, the temperature drops at this stage. Due to these changes, the refrigerant leaves the accelerator as a liquid-vapor mixture, typically in proportions of around 75 to 25 respectively. Throttling valves play 2 crucial roles within the vapor compression cycle. First, they maintain a pressure differential between low and high pressure sides. Second, they control the quantity of liquid refrigerant entering the evaporator. Step 4. Evaporation. At this stage of the vapor compression refrigeration cycle, the refrigerant is at a lower temperature than its surroundings. Therefore, it evaporates and absorbs the latent heat of vaporization. There are different evaporator versions within the market, but the main classifications are liquid cooling and air cooling, depending on whether or not they cool liquid or air respectively. This is it for today's video. Let us know in the comment section which topic you want to see next. Before leaving, check the exclusive offers, link in the description below. And do not forget to hit the like and subscribe button. To find out more on the subject, continue watching the next video.